Welcome to the joy of coding.
Hello, and welcome to episode 137 of The Joy of Coding. My name's Mike Conley. I hope I'm not too loud. I noticed that the gain is maybe a bit hot on the microphone. I'm using the old microphone, this here headset mic, because my someone is borrowing my current sound rig, so I'm having to use this one, and that's okay. We're gonna rock it old school today. Hello, welcome to episode 137. Let's get into it. So what have we got in store for you today? Today is April 25th, 2018. Reminder, no plan survives breakfast. Gonna do my best to stick to plan here, the sort of vague sense of a plan, but it could all go horribly wrong. We might get distracted. We might barely scratch the surface of it. Who knows? We will see. None of this is pre-scripted or pre-planned beyond just sort of things that I'm thinking of looking at today, but I don't have any like back-of-the-pocket solutions ready to roll. I'm flying off the cuff as much as possible here to capture the real development experience. So hopefully that's okay. So first of all, there's that. Second of all, I wanted to shout out the episode guide. The episode guide is completely viewer-driven. Joy of Coding viewers write notes. They append notes. We've got up until last week's episode 136, and some of them are pretty short. Actually, most of them are pretty short, where you'll have like a link to the episode, a link to the agenda, and then maybe some of the topics and bugs we covered. Feel free, if you are a viewer that has your own notes, you want to augment these notes, maybe add some corrections, maybe I got something wrong, or I had a question and you wanted to try answering it, you could append it to the notes. And in order to do that, you should send a pull request to the repository. The notes are all open source in this GitHub repository called Joy of Coding Episode Guide under my GitHub account, Mike Conley, and they're just markdown files, and you can submit a pull request. And if you're not sure how to create a pull request, there's a guide in the agenda right here. And speaking of agenda, I, as usual, haven't told you how to get access to the agenda. So, it depends where you are. If you're watching this on the new Airmozilla, check out the handouts section, which will be somewhere around here. If you're watching this on the old Airmozilla, check the additional links section down below. If you're watching this on YouTube, it's in the video description. And if you're watching this on Twitch, I'm about to drop that into the Twitch chat, a link right now. Agenda, there it is. And there's also a link to rate the episode right here. This is a Google form. It's one per episode. It's a unique one per episode. You can find the link to rate the episode in all of those same places. I'm about to drop it into Twitch chat. There it is. And you can let me know what you think. I read every rating that comes in. Doesn't matter if you're rating an episode from 2 years ago, I'll read it. And I use that to help shape the series. So your feedback's important to me. I think I will not talk about transcription right now, and instead we will move right in. So first of all, a quick self-check. Can you hear me? Yes. Am I recording? Yes. Sounds are working? Yes. Let's play a sound. That's very nice. I'm not going to plug Joy of Profiling today. I think I've done that enough. And instead, let's talk about something near and dear to my heart, which is tab switch performance. So if you are a long-time watcher of the series, you will note that like towards the end of last year and the beginning of this year, we were working on something called tab warming, which is an optimization that allows us to pre-render the contents of a tab when you hover it, so that whenever you request the tab, we can do like what feels like an immediate tab switch. And what's really nice is that if you look at the telemetry, we have this telemetry that measures the time between a user requesting a tab switch from clicking the tab to presenting the layers to the user, and we have that measurement here. FX tab switch total E10S MS. MS stands for milliseconds. Here it's in this little histogram, but we can take a look at the evolution over time from nightly 60 to 61. 61 is when tab warming was enabled very early on, and you can see this nice drop off on the median of of the tab switch time it's nearly instantaneous for the majority of tab switches. If we look at the 75th percentile, we're talking about 5.65 milliseconds for most tab switches that are reported through telemetry on nightly. And the 95th percentile, it's closer to, well, 77 milliseconds, which is not great, but is still a lot better than what it was before, which was 182 milliseconds in the 95th percentile case. So we really took a big chunk out, which is nice. And the other thing we took a chunk out was tab switch spinners. We have this graph that measures how many users see our tab switch spinners at least once per session on a particular build. Tab warming was enabled here, and we see this nice drop. We were hanging around. You can't really see, unfortunately, the text is too small. Well, this is a little bit better. So it was hanging around 45%, just slightly under half of the users on the nightly population. Each one would see at least one tab switch spinner. And then when we enabled tab warming, that number dropped to 35. And then it bumped up again because of some stuff that we landed, and then we found out what that stuff was, and now it's back down to the low 30s, which I'm very pleased about. So fewer users are seeing the tab switch spinners, that's good, and more users are seeing nearly instantaneous tab switches, that's very good. And tab warming is enabled on nightly right now, and I think we are happy enough with it. I sent a message to the Firefox dev mailing list, which actually I will link to just so we have the context here. I sent it yesterday, the Firefox dev mailing list, intent to ship tab warming on Windows and Linux. So here's the mailing list, intent to ship. We'll make that link to the mailing list post. You can see my discussion here. Now notice that macOS is just, what is it? What's the phrase I'm trying to look for? macOS is conspicuously absent, and that's because there is a bug 145.30.80 where we're tracking a regression where warming can cause some animations to appear sluggish. I'm actually able to reproduce that sometimes, and we might actually get a chance to look at that today. But for Windows and Linux, I am sufficiently pleased enough with its performance. Like if we look at, let's go back to the telemetry, actually. Where was the telemetry? I think it was back here. Let's go back to the telemetry and let's look at Linux, because I'm pretty sure we're going to see a similar drop-off for Linux builds as well. So we'll turn off Windows, turn on Linux. And yeah, there's this nice solid drop-off. If we look at OS X, there's, I think, a similar drop-off, but it's just sometimes it's still pretty rough. And especially whenever you're like hovering a bunch of tabs all at the same time. So we might investigate some of that today. But I'm sufficiently pleased with this optimization that we're going to try shipping it for Windows and Linux. So that will go to beta in 61. And in order to do that, we have to flip a pref. So let me pump up the font here so you can see what I'm doing. Because that's what we're going to work on. First of all, is we're going to do the needful in order to get this thing enabled on beta whenever the next uplift happens. So the first thing is all the Firefox specific prefs are in this file called browser app profile firefox.js. This is where all the default prefs are. And the one we are looking at is browser tabs remote warm-up enabled. And so what I want to do is I want to add some conditions here. First of all, I'm trying to remember what the C preprocessor takes else if, right? Else if, because there are three cases. Else if, or is it elif? Elif, E-L-I-F. Okay. So there are three cases. One, you're on Windows or Linux, in which case enable it. Two, the second case is you're on Mac OS and you're on Nightly, in which case enable it. And three is every other case, in which case disable it. So how do I want to do this? What might be easiest to like, I could put a very complicated, like, if Windows or Linux, or if Mac OS and nightly build, then enabled, otherwise disabled. Could do that, but I'm thinking of breaking it up into 3 chunks. So something like elif. It's elif, right? Yeah, elif. Why aren't you recognize? Oh, I guess it doesn't recognize ndif either. All right. Elif defined nightly build, and is there like a Mac? Mac OS X, yeah. If defined nightly build and XP Mac OS X, then we're going to enable it. And do I use and? Or I think I actually use, yeah, and. Like ampersand, ampersand, ampersand. All right, so that is what we're going to do there. If nightly build and Mac OS X do this. Otherwise, if defined, now we want Unix but not Mac, I think. Or XP Linux? Yeah, that might be what we want. XP Linux. Because I'm pretty sure what is XP Linux? We define XP Linux. When? Oh, hey, how's it going? That's all right. Let me pass you your stuff. Sorry, it's a bit.
No, you don't need to apologize. I left this stuff already.
No problem.
I cleaned up after myself.
Just for the folks at home who are wondering what's going on, I am handing. I'm just gonna unplug your laptop here. Is that cool?
A lazy colleague left a bunch of crap in his broadcasting space and is coming to pick it up.
Here it is. There you go, Cannon. No problem. Sorry, it's a bit warm in here.
It's understandable.
All right.
Back to broadcast. Sorry for the interruption.
All good. That was Cannon, everybody. So let's see here. Where is it defined? XP Linux. Here, I think target is Linux. And if the target kernel is Linux, target is OS X, Mac OS X. And then there was like XP Unix is target is Unix if the kernel is not Windows NT. Okay, so what we want is XP Linux. So warm up. If defined XP Linux or defined XP Win, then we're going to enable it true. This feature is enabled by default on Windows and Linux on all channels. This feature is enabled on Mac OS only on the nightly channel until the bug. I have to refer to the bug. Where's the bug? There is a bug. I guess I linked to it in here. Yeah, this one. Till this bug. Till bug such and such is fixed. And I think that'll do it. So if defined, Linux or Windows enabled. If we're nightly and Mac OS, we're enabled. Otherwise, we're disabled. That to me sounds right. So what I'm going to do now is take a look at the patch, the total patch. Looks good to me. Let's make sure it builds properly. So I'm going to do browser app, make sure that our preprocessor doesn't freak out that I haven't put in some kind of weird syntax that it doesn't like. It likes it. So now I'm going to commit. I think there's an active bug here. Yeah, bug such and such. Enable tab warming for Windows and Linux on all channels. And I'm going to have who is good to review this. Florian, I guess, is familiar enough with this. And let's push up for review. And that will take care of the first order of business. That was pretty straightforward. Nothing too challenging there, nothing we couldn't handle. Now, what's the next thing I want to do? Well, I guess what I should do is make sure that this review request gets published, and hopefully lands today. Tomorrow is what's called the soft freeze, when we stop allowing like really crazy things to land in the nightly channel. But the good news is that warming's been on for this entire time, so I'm not too concerned. I feel like it's gotten decent test coverage. Let's take a quick look at the pref patch. So I'm going to add a comment explaining that, like, I'm aware that I could have made that a single conditional, but I thought this would be more readable. Alright, so that's done. Posted for review. And that's not supposed to have a link. So I will right click, link, remove. What? There we go. I just pasted without style. That's what worked there. So I have an update. Now that that's up for review, that's sitting there, sitting pretty. I guess I'll update the state in my notes here. That's how I like to keep track of how things are doing. So I'm gonna say blocked on review, put a tag there, blocked on review. And let's go back to our agenda. So I have a quick update on another patch that we were working on a couple weeks back, maybe even last week. What did we work on last week? I think, yeah, we were talking a little bit about it last week, or last episode, and then the episode before that, and maybe a couple episodes before that. I think we first started working on it like back in, did we have a, I don't know when we started working on it, but a couple weeks ago anyways. And it landed. So what we have now is we have this patch that removes this layout flush that was happening every time you hover links. So for example, I've got oh no reflow here. This is this thing that counts how many synchronous layout flushes we do. And notice now that when I'm hovering links, I'm not getting layout flushes being reported up here, which is really, really good, because you don't want to have to flush layout every time you hover a link, or even risk flushing layout every time you hover a link. So we got rid of a layout flush, which is really nice. We still have a bunch of layout flushes elsewhere to deal with, but we are slowly making progress taking those layout flushes down. But when it landed, so it landed, and what happened was after a little bit of back and forth and dealing with some test failures, it landed, and then what's called a Talos regression was filed on it. So what that means is we have these performance tests called Talos tests, and we have this one test called TP5. And what it does is it loads a page. It loads this like set of pages that we've saved from the internet from back in 2011, I guess. It really needs to be updated, but 2011, and TP5 counts how long it takes to do certain operations with those pages. Usually it's like how long until we can like load it and paint it. One of the things it also measures is responsiveness, and it measures this on Windows and Linux. And the way it does that is while the test is running, it will periodically on a different thread fire an event into the event queue, a tracer event, to see how long it takes for that tracer event to be serviced. And after a certain threshold, or like we count how long it takes to service those events, and we take a score. Like we look at the delta between the time we dispatched it, we queued it in the event queue, and the time that we serviced it, or it got serviced by the event loop. And we look at those time deltas, and if the number is greater than before, like we average them all up over the course of all the events firing and whatnot during the tests, during the loading of these pages. And we do like this, we square the results for each value. We square it and divide it by like 100,000 or something. I don't know why we do this operation, but the higher number means we are taking longer to service the idle events than before. And that's what's happening is there's been a 22 to 34.46 responsiveness drop since the patch landed. And although Chris Maglione makes a good point here, it sounds big. 22 to 35 or so % drop is in responsiveness. It sounds big, but it's pretty ill-defined when it comes to E10S responsiveness regressions. 0.31 to 0.41 is probably not a user observable difference if it happens in consistent small chunks. If it happens in 3 or 4 big chunks, it probably is. We really need some responsive numbers broken into percentiles. This is true, but we don't really have that right now. And so the good news is that I think I have this reproducing. This is what I was hoping we could investigate today. It's a little bit of a WTF situation. I have no idea what's happening. I've gathered a couple of pieces of information, and I'm going to share those pieces of information with you now. So first of all, I can reproduce this issue on beast mode, my VM, which I have here. And the other piece of information is that in order to run this test takes about 3 or 4 minutes to run. And so we'll probably end up splitting our time between this problem and a different bug, because we're going to be waiting for test runs to get data back. Luckily, I can do it locally instead of having to push to automation. So this is the list of pages that's loaded, and this is where I'm running the test. Right now I've got a responsiveness score of 0.75, and that was on the, let me copy that to the clipboard, on the bad, I've got two bookmarks here. Let me pump up the font. I got 2 bookmarks in my in my mercurial tree here. Bad being with the patch, good being without. And what I'm trying to do is I'm trying to reduce the test case so that it takes as little time as possible in order to run the tests. Because the smaller I can make the feedback loop, the better my chances of finding a solution quickly. And I tried reducing the number of pages that we're loading, and that made the signal go away. What I've done is I've reduced the number of cycles for page loads. We used to do 25, now I'm doing 10. And I've reduced the number of pages by roughly half, but any more than that, and the signal seems to go away. So right now I'm back to a 43 entry list, and we're going to see if there is a distinct difference between bad and good. And a distinct difference would be like I don't know, something like this was a distinct difference. So like in .1 units difference. That's a difference. That's a difference worth recording. So while that's running, what do we do instead? Because we're waiting for this data, and as I was saying, we need to start thinking about other things while that's running. I wanted to go back to that thing that's preventing tab warming from shipping on Mac OS. And this is, I think, going to be more of an exploration, or like trying to figure out how our graphics subsystems work sort of situation. Because I was speaking with some graphics folks over the lunch break. I just had lunch not that long ago, and they gave me some hints on things that might be causing the performance regression. So the first thing to note is that we can reproduce this issue. I've got a bunch of tabs here. I've got this sort of test profile, and if I run my mouse over all these tabs, notice that like especially early on, whenever I like run my mouse over these, there's like a little bit of lag in the highlight. I'm trying to find a good example here. Like there's some lag in the highlight. It's taking a while to catch up. What is going on? What's it doing? And then if I disable warming, so I can do that at runtime. If I disable warming, then the lag seems to go away. Okay, so that's one piece of information. The second piece of information is because we can reproduce it, that means we can profile it. So I'm going to stop profiling, start profiling again, and see if we can gather a profile. Yeah, there. We stuck a little bit there, and now I'm going to dump a profile, and let's see what it says. I'll zoom that in a little bit. And this is the sort of thing that I was showing the graphics team. These are long paints. These green areas in the profile, which I'm gonna zoom in on here. These green areas of the profile are paints, and some of them are really long. This one is 79 milliseconds. This one is 33 milliseconds. They're quite long, and we do 2 of them usually, which that might be a separate problem where we're doing 2 paints. And I don't know why we would do that. Layer tree ready. I think we do it because the refresh driver tick shows up and we decide to paint again. And I'm not entirely certain that's necessary. Where is the event that's like, hey, I have your layers. Marker chart. Pause after paint. Doesn't come up. But we do upload the layers here. Like we paint here, we paint here. There's just like a lot of stuff happens. A lot of painting happens at the same time as I dragged my mouse over things. We just spent a lot of time doing stuff, and the majority of the time seems to be spent. Here, let's just look at this one thread. We'll get rid of process 1, 2, 4, and 5. We'll just take a look at this one thread. And I was showing this to the graphics team, and they recognized what was happening here. I'm interrupting. I was interrupting JavaScript to paint. And what happened was I painted, and the majority of the time painting was spent trying to allocate a texture client. And apparently, if I look at get texture client, we try and get a texture client from the pool, but we initially allocate M initial pool size from our pool. If we can run out of texture clients, we allocate additional texture clients to try and keep around M pool unused size. This is what's happening is our texture client pool is empty. So we allocate a texture client, I think. Yeah, right here. And that appears to be pretty expensive. And so what the graphics team was saying is maybe we should be smarter about the pool size. So M texture clients is this collection, and I don't know how we decide how big it can be. Allocate texture client, and we push it in, and then pool unused size, shrink timeout. There's this effort to try and shrink the number of texture clients. Yeah, to clear pool after a period of inactivity to reduce memory consumption. Try and reduce the size of the pool. And we need to first of all see if there's a way we can clear callback. Texture client pool clear. Let's go to that. So what it'll do is while it's not empty, we go through each of the texture clients and we pop them. And while the deferred ones aren't empty, we go for outstanding clients and we pop those. Okay, and I guess we destroy them. How do we know whenever, or shrink to maximum size, wherever our desired maximum size, immediately shrink down to the maximum? Total unused texture clients is the client size plus texture client's deferred size, and the initial, if we have greater than the initial pool size outstanding, then we want to keep around pool unused size as a maximum. If fewer, keep around the entire initial pool size. While the total unused texture clients is greater than the target unused clients, pool unused size or initial pool size, and we use, so this is what we want the number to be, and it's outstanding clients. If we have greater than the initial pool size outstanding, we'll keep around M pool unused size at a maximum. If we have fewer than M initial pool size outstanding, then keep around the entire initial pool size. What is M pool unused size? How many unused texture clients to try to keep around if we go over the initial allocation? How many unused to try and keep around? And the initial number of unused texture clients to seed the pool with on construction. And how many unused texture clients to try and keep around if we go over the initial allocation? And if the number of outstanding clients, this is the total number of clients in the while in the stack of deferred clients. So the total number of clients in existence is always M outstanding clients plus the size of texture clients. Total number of clients in the while in the stack of deferred clients. So the total number of clients in existence is always outstanding clients and the size of the texture clients. Clients in the wild and the size of deferred. And then initial pool size. So I think initial pool size is what we want to try manipulating for now, just to test. Initial pool size. So here we construct with the initial pool size 1, 2, 3. So it's 1, 2, 3, 4, 5, 6, 7, 8. The eighth argument to the constructor texture client pool. And here's where we instantiate one. 1, 2, 3, 4, 5, 6, 7, 8. Initial pool size right here. That's the value. And it is this pref. Layers.tile initial pool size. So it starts with a count of 50 for some reason. And let's see if we know why 50 was chosen. Meanwhile, let's go back to, oh yeah, this test is done. So value for, what was this, bad? This was good. This was good. So yeah, there's a bit of a drop there between bad and good. And so we can detect the problem. I'm back to the responsiveness issue, just so you know. So this is, how long did that take? Did it say? Wall time 294 seconds, so 294, 6, 1, 20. So yeah, a couple minutes. About 5 minutes. Yeah, about 5 minutes or so. So that's what we're going to be doing. We're going to be running this test. We're also going to be seeing if there's something we can do about this. One thing I have realized is that the bad case, update bad, the bad case, which is here, the part where we seem to be able to influence the score is here in this function called add listener. I had to refresh the file. And window.promise document flushed doesn't appear to be the expensive part. It's this request animation frame thing. So if I just call request animation frame and don't do anything inside it, I believe, if my memory serves, we still get the regression. So let's double check that. So 43 entry list for TP50 are bad with only request animation frame. We'll get a score here. So we'll get this test to run again, and we'll go back to the other problem. Where were we? Oh, it was over here, yeah. So 2 years ago, I think this should just allocate 50 texture clients on startup, then keep recycling them and never need another allocation. If it does, then it allocates another 50 when the unused pool becomes empty, and the pool effectively becomes 100 clients. It'll shrink down to a maximum size of 50 unused if we end up returning a lot of texture clients and don't use them again. I've removed the shrink to minimum size code as I don't think that makes sense anymore. Clear is now used for memory pressure events. I'm wondering if clear should be renamed to discard unused tile to be a bit more explicit about what it does. Jamie Nicole says, I'm concerned about that allocating 50 tiles at a time is too much. That's 200 megs with a 1024 by 1024 tile size. Maybe we need a slightly more complicated scheme. Aim to keep around 10 unused tiles during normal usage. That should handle scrolling well without using too much extra memory, but it's not enough for tab switch. So maybe we always want a minimum of 50 tiles, including outstanding ones. If we call this here, then it's down to chance whether we have unused tiles lying around. Okay, I tried a bunch of allocation strategies and settled on this one. Basically, we allocate initial budget. If we run out, we allocate in tens and keep track of our unused pool size to ensure that we always have at most 10 unused tiles in the pool, discarding as necessary when tiles are returned and defer return to us. In order for this patch to work properly, we need this. I still see tile allocations and scrolling on my MacBook Pro. Spun that off here. page really, really badly. Assess pool size values and adjust accordingly. So this all sounds reasonably relevant. Currently, the strategy is to seed the pool with initial number of tiles, currently 50, but preferable. And if we exhaust that initial supply, we grow the pool by an increment number. Keep doing that until the need is satisfied. Trade-off between memory usage and allocation tabs means that we can have up to 9 unused tiles sitting around waiting to be used. You shrink the pool if we have greater than 10 unused tiles, and we also completely clear the pool if we hit a memory pressure situation. Hefty layerization. Fixed in 51. And what did they do? They made it so that we increment one at a time, but by default, but by 10 on mobile. Oh, what was the default? By 10. Wait a second. Layer tile pool increment size. Tile pool unused size. Okay. Shrink the texture client pool to maximum. So there are some prefs for us to mess around with. The shrink timeout, the clear timeout. Wait after texture is returned before trying to clear the pool. How do we clear the pool? 5 seconds. So we have shrink timeout, clear timeout, unused size, wait a second, that went to 10? I thought they turned it to 1. Increment size, that appears to be gone. Increment size is gone. So how much is it incremented by now? Layer, texture pool, or texture client pool, that's what it's called. Texture client pool. Increment, no. Clear initial pool size, pool and use size, clear timeout. What was it? Increment size. Allocate texture client. Create for raw buffer. Force shmem tiles. What's force shmem tiles? Merge tiling branch. That's false. That might be interesting. Shared memory tiles. So what we end up with then, what if instead of one pool per content process, we have one pool that's shared between all the content processes? Whoops. Force shmem. Size backend. We create a pool. Each client or each content process would still have this notion of force shmem tiles. I'm less confident that shmem tiles will be useful. Reset timers, return texture client. Client to the pool. So first thing we can do is probably increase the, let's see what happens when we increase the initial texture client pool. Initial pool size, it starts at 50. Let's flip the pref so that we start with, oh, I already did it to 150. And I don't think it's helping. Like, I'm still seeing like a bunch of lag here. So that's not really helping. And the profiles are probably the same, or we're still allocating a bunch of memory. Yep. Oh, some of these are a little weird. Look at this. One paint, and then a hang, because why? We're waiting on something. Flush async paints, where we're waiting for like the paint thread. This is less about allocating and more about the paint threads. I can take a look and see what's going on now in the paint threads. So we'll restart the profiler, put that away. Start up the profiler. Get our lag. Capture. Lithium X4900 goes, they actually do use Bugzilla. Yes, yes we do. We do use Bugzilla. Holy smokes, what's happening here? Main thread's going crazy. Paint threads are all busy. Oh. Why so busy? Paint worker. Let's take a look at one of these. Don't need content 1. Don't need paint thread. Don't need paint worker. Don't need oh, we'll keep content 2. Paint thread, paint thread. Not doing much there. Doing much, not doing much. Content 3 wasn't doing much. Paint thread. These ones weren't doing much. Oh, that content process was, though. And then these paint workers were doing some stuff. And so are these paint workers. Okay. So what's happening is hovered over a thing, rasterized, still allocated a texture pool, client pool, texture client pool, and then we were waiting to flush async paints. And so these, after allocating the shmem, we were drawing on 3 different threads. And meanwhile, this one was also painting. But this one was also allocating a texture client. And once that was done, then it started asking paint threads to paint. Just doing too much. Just doing too much. And like, let's see, memory-wise, how are we doing here? Yeah, it's not great. OBS is taking a bunch of my CPU. Like, notice how whenever I like hover these, I'll bet the memory's gonna just skyrocket. No? Ooh, 1.06 gigs. 1.03. And then back down. Dropped a bunch. It's like it goes up, it goes down. We're up here, we're got a bunch of stuff allocated. What's the story? It's just too much. Too much. So one thing I want to understand is maybe we need to be a little less aggressive with how we're warming whenever we notice the user's just like moving their mouse over some tabs. And what might help is if I have some visualization of how warming is working. Meanwhile, what happened here? Did I get my test run? I did. Where's my result? Right here. So bad with only request animation frames. Yeah, I think that's still in the realm of badness. It's kind of halfway. Let's try it again. So run it again. Run it again, Sam. Meanwhile, so we'll run it again. We'll add another number there at the end. Meanwhile, I think what I want to do, excuse me. Excuse me. Just catching software development in the raw, sneezes and all. Kaz says nothing, just nothing. What I'm going to do is I'm going to shut down this Firefox. What I'm going to do is I'm going to instrument warming anytime a tab is being warmed. It's ready. On layers ready. Set tab state. I think that's what I want to do here is in set tab state, I'm going to decorate the tabs visually. Here, tab.set attribute, tab state, or state, and then I'm gonna add some CSS, tabs.inc.css. Background, tab background. Tab background. Tab background. What am I going to do? State equals, I've got these numeric states, so I have to look at them now. State unloaded will be 0, so we'll leave that. 1 is loading. We'll say background color is yellow. State 2 loaded, make it green, and unloading will make red. Let's see what that looks like. No idea if that's gonna even be visible, but let's see. Let's just see what it looks like. Oh, not debug, build with default. It was using my debug profile for some reason. Oshkosh gabosh. How's my computer doing? What are you waiting for? Kernel task, crash plan, what else? OBS. Okay. That's what I wanted. Okay, and now this test is done, 0.70. So, worse than before, but not as bad as what we were doing. So just running the request animation frame, like if I get rid of the request animation frame, what happens? So this is like bad with only promise document flushed. Meanwhile, back at the ranch, let's see if our tab warming highlighting code helps. Visualize. Okay, so my machine is suffering. Too much happening. Too much. Stop. So right away I can tell you that it's not working as I had expected. So I'm gonna quit. I also want to understand why my computer is so slow right now. The encoder was overloaded. Some kind of crash is now being reported. Alright. Let's run it again. And I'm also going to open up the JS debugger. I don't actually want to debug JS, but I do want to use the CSS tool, see what is up. Maybe I have to add some importance or something. What? Why didn't that work? Connection status. I was complaining about that. Alright, maybe I'll start a little simpler. I'm going to close this tab, and this tab, and this tab. I'm going to close a bunch of these tabs. Just like get rid of some of the load on my machine right now. There's just too much happening. Computer can only do so much. Calm down. Just calm down. We'll open up the browser toolbox. That's a pretty neat graphic from the Guardian. Alright, what state is the tab in? Did the attribute get set? So I'm expecting that these tabs are having the attributes that I was working on getting set. Oh boy. Oh, you know what it is? It's because tab background, yeah, it has the state 2. I know what the problem is, so we're going to quit. The problem is that the tab background is not the one with the state. It's the tab. Tab browser tab. Tab stack, tab background. That's how it works. So it's tab browser state. It's like this. When the tab has this state, then apply this rule. 1, 2, 3. Whoops. And this is done. So that went down a little bit. With only promise document flushed, it actually is closer to just the good case. So causing a request animation frame, the evidence suggests that a request animation frame is enough to cause the event tracer to slow down. Why is that? Like, I could also just like get rid of the request animation frame entirely and do this. Call listeners and then on tracking started. So this is what essentially we were doing before. So add the listener, call the listeners, say that tracking started. And let's see what it thinks of that. Meanwhile, back in my local build, did I build faster? I think I did, but I'll do it again. OBS takes a ton of my CPU, just an absolute ton. All right. What the? Close this. Go away. Dialogue. Give me back my event loop. Maybe I do need the browser toolbox again. Man. To be fair, to be clear, whenever I'm not streaming, my computer's significantly faster. I wish there was some way I could offload what OBS does to another computer. There's probably a way. Tab background. So the tab has what? Tab browser tab. Make sure it has a state. Tabs doesn't have a state attribute set. What the heck? I thought I was adding state attributes. Get attribute state. Okay, set attribute state. There, that's what I want. So the CSS is correct. It's just for some reason now the state's not being applied. Let's find out why. Async tab switcher. No action. So why didn't the tab have the state attribute set? It should have. Oh, now it has state 0. That one has state 2. Great. Yeah, this is what we wanted. But if this one has state 2, how come style is not being applied? State 3. State 2. Rid of that breakpoint. I got a feeling my tools are lying to me. State 3. Set attribute state. Hello? Set attribute state 3. And it crashed. What happened? Panicked. We were lied to. Stylo. Whoopsie daisy. Assertion failure. We're failing a bunch of assertions. Here, let's try this again. Something's wacky. Nice and simple. There we go. Okay. Now what about the unloading state? Set tab state unloading. Unloading is 3. So why wasn't it turning red? I'm also going to say that this is important to override. And instead of yellow, I'm going to make it orange. Red, important. And how come when we were unloading, we do this thing where it was like unload, what was it? On swap doc shells, on and swap should activate. Request tab, queue unload, on unload timeout, unload non-required tabs. Set tab state unloading. Alright. So let's try that again. So what was this test run now? This was doing the old thing. Which is similar with just request animation frame. How about this? So we get rid of the promised document flush part. Run that again. Okay. What? Now it's not highlighting at all. Did I get my rules wrong? Make sure that we Also handle the selected case. Maybe that will be better than using important. This is just some sloppy stuff. I feel like I'm losing my mind here. What's happening? What's happening?
I can't do my work!
Why is that not happening? Oh, there it is. There's one. Okay, this is good. I want to override the selected style though. So I'm going to go back to important. Background image. None. Background color, border top color. And why am I doing this? I'm trying to get a decent visualization of what's happening with our tab warming. And who knows, maybe this is the sort of thing we could like land in the tree behind a nightly only flag or something. Right, so it's because we don't warm the currently selected one, that's why. So now let's open up a bunch of tabs. Have them hang around in the back. Now what's interesting is that we attempt to warm I think I also have a single content process. That's probably not helping. Yeah. Yeah, that's totally not helping. DOM, IPC, process count. Oh wow, no, I've got 4 different processes. Pause, enable, shutdown. It's just my machine's really slow. That's what's going on. So what's interesting is we attempt to warm up a bunch of tabs. Wish these would stop like loading. Why are they here? Let's load something a little more reasonable in the background. Example.com. And we'll open this. Whoopsie daisy. Huh. Whoops. Accidentally closed the window. Because middle click closes. There is a way of cloning a tab. I can't remember what it is. Doesn't matter. Example.com. 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 Whenever I open a tab, the previous tab stays green for a little while. Is that because... I guess, yeah, we keep it around until we unload it. Okay. Let's just see here. Warm layers ready. Warm layers ready. Warm layers ready. This is kind of like what you want. Instantaneous tab switching. So what I'm thinking is, one thing we could do, because notice we'll hit our maximum, which is 3. 3 tabs can be warmed at once. And as soon as we hit those 3 max, we still attempt to load the other ones, but we queue the unload of the other ones. So all of a sudden there's a lot of work going around. And what I'm thinking is, one thing we could do is make it so that if you've reached your maximum and the current number of tabs that are warming has not dropped to 0, if you've reached your maximum, do not attempt to warm can warm tab. Should warm tab. If state equals state unloading or state unloaded. Warming tabs. Max warming tabs. Where's the max warming tabs limit? Max warm. G tab warming max. Hit tab warming max. If when the number of warming is greater than G tab warming max, then we do this. After we calculate the number of warming. What if we say, if this dot warming tabs dot size is greater or equal to G tab warming max, return false. Let's see what that does to our behavior. Back here, we got a responsiveness value of this. And that was when we did what? We were doing things without promise document flushed. Now what if we did everything except we don't use the request animation frame? Then what happens? Just doing more experiments. No request animation frame. And I think I'm going to wrap up this episode in a couple of minutes. But we've got some interesting insight here into tab warming behavior with this visualization. Okay, so now let's see what happens. We'll still warm even though because I guess the unload happens before the next warm-up. Because the warming tab's length drops to 0 once the unload begins, but we could still be unloading those tabs. I see. So what do we want to do about this? The user's just kind of running their mouse over this. At some point we should probably stop warming because we're just burning CPU. I mean, what if we reduce the number of warmable tabs from 3 to 1? also keep painting if we just like time out and the mouse is in here. All right, well, this is a useful tool, I think, a useful visualization of what's going on. So didn't do too much today, mostly just getting some data. No request animation frame, you're down to about there. That request animation frame is pretty expensive, eh? Why is that? The request animation frame. I'll run it again. Alright, I'm going to cap it there. Thank you so much for watching episode 100 and... what was this? 37 of The Joy of Coding. I hope that was enjoyable. I don't know what else to say. You were a great audience, and I hope to see you next week. Don't forget to rate this episode. Let me know what you thought. I read everything that comes in, and I want to know. So have yourself a great week. Take care. Bye-bye.
The joy of coding.
See ya.